Good afternoon, ladies and gentlemen. In this short video, I'm going to go over sine, cosine, and tangent. But before I do, I want you to get really good at adding vectors. So I've offered you guys extra credit if you do this worksheet. I'll do most of it here, or a good portion of it for you, because if you really understand how to add vectors, then you'll be able to go backwards and resolve vectors to its components. So if you have a strong foundation adding vectors, then you'll be good to go when we start using this for velocity in 2 dimensions and as well in forces in later chapters. All right, so important. Here we see 2 vectors. We're going to start with the upper right-hand corner. I'm going to go ahead and zoom it in. We see 2 vectors, and they seem to be exactly perpendicular to each other. And the question is, how do we add these 2 vectors? So remember, a vector can be anywhere we want it to be. So it doesn't have to be here. And remember, I have to have head to tail. Well, right now, both the tails are touching, so that's not okay. So I can move this one or that one. Let me go ahead and label. This one is the A and this is the B vector. All right. So I'm going to move the A one over here. As long as it has the same dimension or the same magnitude and the same direction, then it's exactly the same. So there's the A vector. So I want to add A plus B. All I have to do is start where I started and end where I ended. So I'll use my marker here. Oops. Here's my straight edge. All right, start where you started and end where you ended. And there is my resultant vector. Okay, we can say R for resultant vector. But what if I hadn't done that one? What if I said, no, you know what? Prove it to me. I want you to redraw the B one instead. Okay, so the B one, I want to go to this A on the left side. So I'm going to draw it from the head. Here we go, head to tail. So the B is over here now. And you'll notice that this A vector plus this B vector, I start where I start and I end where I end, and we end up with the same resultant vector. So it doesn't matter which one you choose to move. All right, let's say, well, I sort of get that. Let's do it again. I'm going to let you guys do this one, and let's do this one. What do you know? It's just one of them's going to the left. So where this is in the positive direction, B is pointing to the right, the magnitude would be positive. This B is to the left. All right, so we're going to call this B, and this is A. Again, I can't add them just the way they are right now, so I have to move one of them. Let's see, last time I moved the vertical one. So this time, let's move the horizontal one, because it doesn't matter. So from the top of A, I'm going to redraw the B vector, and it's going to be exactly the same magnitude. There's my B vector. All right, so now I have to start where I started and end where I ended. Doesn't look like I went far enough with the B. Maybe it's supposed to be out to here a little bit. All right, start where I start and end where I ended. There we go. And there's my resultant vector. Okay, there's my resultant vector. So I'll let you guys do that one. Very similar. You get really good at this. All right, let's see if they're not 90 degrees. Now what do we do? Oh no, I only know how to do them 90 degrees. No problem. Let me label them. Let's make the A and this one B, just for discussion's sake. And I'm going to move the A. Let's move this one. And let's move it all the way over here. Move it over here. I'm going to assume those 2 lines are perfectly parallel. Perfectly parallel. And I'm going to the right, here we go, to the right exact height. And now I know that's exactly the same vector. Remember, we don't know where a vector starts. All we know is its magnitude and its direction. Okay, now I can legally add these 2 because I have head to tail, head to tail. So I start where I started. Here we go. I'm starting with the B plus the A. Start where I started and end where I ended. Here we go. Start where I start and end where I ended. And you say, well, prove it to me. What if you had moved the B vector instead? Okay, that's this horizontal one. Let me move that from the A. So I've got to move it to start it way over here. And it's got to be the same length. In other words, the same magnitude. And here we go. Same magnitude And sure enough, if I add this A plus B, start where I start, end where I ended, and I get the same R, same resultant vector. All right, so I'll let you guys do that one. Let's take this one now. They're both going down. Okay, I'm going to label this one A and this one B, and you have to make a choice. I can't add them the way they are right now. So this time, let's see, last time we took the sort of vertical-ish one. We'll take the sort of horizontal one. Oh, this one is horizontal. Okay, so let's take the horizontal one. I have to start way over here, and it's going to the left, and I have to go the same exact magnitude. Same exact magnitude. Hopefully be able to visualize a parallelogram because I have to go the same. You could measure that and see how many inches it is and go exactly the same amount of inches. All right, so I'm going to say that's the A. And now I can add A plus B, start where I start and end where I ended. And end where I ended. Here we go. There it is. And there's my resultant vector. Okay, so it starts where you started, ends where you ended. So again, if I had chosen to draw the B instead, let me draw it this way. I'm going to take this B one. Let's see. Oh, I can't find my yellow highlighter. Take this B one and move it over. I can show you that I'll end up with the same resultant, The A plus the B, I end up with the R. Same one. And I'll let you guys do that one. Now, the reason I would like you guys to have the experience on doing that is so that you can go in the opposite direction. What do I mean by that? This one here is the resulting vector. So your challenge is to break it down into the horizontal and the vertical. So here's where you have to imagine somehow a right triangle. A right triangle that when you add up those two vectors, they would add up to your resultant. So let's see. Well, I can see if I go sideways here from where I start. Let me go this way instead because I see the dashed line. I'm going to take this one and go down. And I take this one and go to the right. Now, just drawing this part is not enough because the vector has a head and a tail. So here you need to decide, well, what direction? How about if this one goes to the right and then this one goes up? So if I have an A here to the right and my B going up, did that work? Yes, it did. I start where I started. I add the head to the tail and I end where I ended, and there's my R. So what you just did was you broke down the horizontal component and the vertical component. Okay, that's what you're doing here. And this is really a good, important skill you'll have to do as we move along the next few chapters, including this one. All right, let me skip this one, let you guys do that one. What about this one here? This one's kind of pointing, if this is north, we'll say that one's pointing northeast, and this one is pointing northwest. So how do I break down this vector? Okay, same thing. Need you guys to visualize now an exact right triangle. So I see the dashed line, and that kind of helps me. And I'm going to draw a dashed line parallel using that resultant vector. And now I can draw the horizontal one using that vector. Oops, there we go. Which direction does it go? It has to go to the left, call that my A vector, and it has to go up, call that my B vector, and that's how I'll end up with my resultant vector. Okay, should we do another one? Let's see, I'll let you guys do this one. Let's see, I'll do one more here on the bottom. Here's another one. This one's going, let's call this southwest. Southwest, okay, and it didn't draw any vertical line, so I have to draw the vertical line. So I'm going to take my straight edge and draw a vertical line going down, okay, and I have to go the right distance so that my two vectors, when I add them up, this is my resultant vector. Here we go. This one's to the left and this one's pointing down. Now, if I add up the A and the B, A is going down, B to the left. This one's going down, this one's going to the left. And now I have head to tail, so I start where I started, end where I ended, and that's the correct resultant vector. Okay, should we do one more? Let's take a look at this one here, second one. All All right, so I see it's going also northwest. I need to visualize a right triangle. Let's see, I'm going to pick this one only because that dash line is already there for me. And I'll take the dash line. Those better be perpendicular. There we go. Not perfect, but okay, so this one's going to the left and this one's going up. There's my A and my B, and I end up with the resultant vector. Okay, so I really believe this is a good exercise for you. Then you'll have no trouble resolving your vectors. Okay, as I promised, now we're going to move to sines and cosine. So I gave you guys this handout, has a little dog on there. That should be on your packet when you picked up for the semester, the packet. So here it is. Here's the review. Let's see if I can move this out of the way. Here's the review. Okay, so we have an angle. Here's our vector. And notice that there's a little arrow on top. You'll see some books use that to show it's a vector. So what do we know about the vector? We know its magnitude, whatever the absolute value is here, whatever it is, and its angle. Because you have to have the angle and the magnitude and the direction. So the direction is one way you can say angle. This angle could be, let's say it's 45 degrees north of east. Or you could say this angle over here. Either way, that'll show you exactly where this vector is. All right, so this vector, we took it and we broke it down into its components. This is why I wanted to go through that other part. So here's its components. Here's the x component. See that little vector there horizontally? That vector v sub x plus this vector v sub y, when you add those vectors, you end up with the vector that in this case we started with. So this is called the resolving a vector. We resolve it to its x component and its y component. And we need to know exactly how big this is. If they tell you that this is 500 miles per hour, and you need to know what it is in the x direction, what it is in the y direction. Okay, so how are we going to figure that out? So let's look at what sine is. Sine is opposite over hypotenuse. I think I'm going to do it over here. Well, because this is already showing you how to figure out your resolved vectors. Okay, and so we'll get to that. Let me start with over here, this triangle that I drew you guys. Okay, off the table, sadly. All right, it's over. Okay, so I drew this triangle for you. I just took a graph paper and I counted up the little boxes. And it says that it's 18 and this one's 26. Now, I know that this is a right angle, so I know I have 90 degrees. So the question is, how big is this angle right here? Let's call it theta. And how big is this angle? Let's call it alpha. Yeah, we use Greek letters a lot in science, particularly in physics. Alpha, and I don't know what those are. So here's a good way to start reviewing. So what is the sine? You guys remember sine is the same thing as opposite over hypotenuse. Okay, I don't know what the hypotenuse here is. I could figure it out with the a squared plus b squared equals c squared. That's what the sine is. Okay, sine is the opposite over the hypotenuse. So this one's my hypotenuse. Hypotenuse. All right, so I better write that, hypotenuse. So sine would be opposite. You have to visualize outside of this angle going out. Oh, opposite is this side right here. Okay, so kind of look at a cone going out. The cone going out, 18 is the opposite of this angle. All right, and likewise, the opposite of alpha, the other side is 26. And this guy here is the hypotenuse. Okay, all right, what's the cosine? Cosine is not the opposite, it's the adjacent over the hypotenuse. So the adjacent is the opposite of the sine because you only have three choices. You have the opposite and the hypotenuse and the adjacent. So if theta, if the opposite is 18, then the adjacent is 26, right? And the last one, tangent. Tangent is equal to opposite over adjacent. I'm going to start with that one because I didn't take the time to figure out what the square root of 18 squared plus 26 squared is to figure out the hypotenuse. So I don't need it because you only need two pieces of information. Well, three, there's a right triangle here to figure out what one of the angles, and then I'll know what the other angle is. So who's the opposite to theta? It's 18. So let's say it's 18 18. And who's adjacent to theta? 26. 26. Okay, so I told you guys I like the term arctangent instead because it's not the inverse. You're not putting 1 over it. So theta is equal to the arctangent. My calculator's here. Here we go. All right, so I'm going to do arctangent, use the green button. Arctangent, 18 divided by 26. And I get 34.7 degrees, 34.7 degrees. All right, so this angle I know here is 34.7 degrees. Okay, 34.7 degrees. All right, so let's see. For this angle here, it would just be 90 plus 34.7 and subtracted from 180. But let's say you didn't remember that. I'm going to do it using the tangent of this one right here. Let's do that. Let's do the tangent of alpha. Who's opposite to alpha? 26. 26 over 18. Over 18. All right, so what is that? Alpha is the arctangent of 26 over 18. Let's do that. The arctangent of 26 divided by 18, and I get 55.3. 55.3. Oops, 0.3. 0.3. Now, let's see, what is that plus the angle I got above it? Here's an example why you want a scientific calculator. Plus, I'm going to go plus 34.7. 34.7. Sure enough, it's 90 because the angles inside a triangle all add up to 180. Okay? All right, so that was just a review of using the tangent. For a sine and cosine, you have to know the hypotenuse. So let's say for the next example here, we are going to start with the hypotenuse. So how do I figure out the hypotenuse? I counted up the little boxes here, by the way, 26 and 13. So this hypotenuse, I'm going to call it C here. Okay, what is C? C is going to be the square root of 26 squared plus 13 squared. Why is that? Well, because hopefully you remember that A squared plus B squared is equal to C squared. Pythagorean theorem. So let's do that. Let's figure out what that is. I'm going to do, give me the square root. You see that? Square root of 26 squared plus 13 squared. Lost the squared button here. There it is. There it is, 13 squared. What is that? 13 root 5. Well, that doesn't help me. So there's a little button here to hit this one to give me the whole thing. All right, 29.07. So it's about 29.07. 07. So we'll just round it off for us to be 29. Okay, so we're going to say it's about 29. Okay, cool. Now we're going to practice the sines and the cosines. All right. So we want to know what theta is and we want to know what alpha is here. What are those angles? And we're going to use sine and cosine instead. Okay, so sine of theta is opposite over hypotenuse. Hypotenuse. Now, who's the opposite? It's really important. You got to take this guy and fan it out. Oh, that's this guy, 26. So 26, and the hypotenuse is 29. 29. All right. So therefore, theta must be the arcsine of 26 over 29. See what that is. Oh, I'll leave that in there. No, I guess I can't. Well, I can, but let's just clear it. All right, arcsine. This time we're going to use the arcsine here of 26 divided by 29. And I got 63.7. 63.7. So obviously, what is that from 90? I'm going to say minus 90. So the other one's going to be 26.3. But let's say we didn't know that. We have no clue what the next one is. So we know that this one here is 63.7. All right, degrees. So I want to know what alpha is. Let's just stick with alpha and let's do the sine. Or I guess we'll do cosine now. Let's do cosine. Cosine of alpha. Just to review, cosine of alpha, it's not opposite. It's adjacent over hypotenuse, adjacent. So I always look at the angle and say, who's opposite? Boop, 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 13. Oh, that's not the one I want. I want 26. Okay, again, from alpha, not the opposite, but the adjacent. So it'll be 26 over the hypotenuse, 29. Okay, same thing. So we do this guy again. I want to know the arc cosine of 26 divided by 29. And I get, sure enough, what I got, 26.3 degrees. So I know that this guy here is 26.3 degrees. Okay, so what does it mean to be resolving vectors? Let's say that our resultant vector is this puppy right here. This puppy right here. Boom, it's going this way. Let's say it's 29 miles per hour of a rocket, and you did it at a 63.7 degree angle north of west. You guys see that? North of west? Here we go. North is up, south is down, west, east. Okay? So we want this angle, this is northwest, isn't it? It's over here in this angle, in this quadrant, northwest. So you'd say it's north, oh, I take it back. North of west is this part right here. North, no, that's right, north of west. So this is north of west. That's this angle here. Because the angle on this side would be, what is that? North of west. North of west is right here. North of west. Yeah, because this means you start west and go north, 63.7. Okay, so let's say all they gave you was given. Your vector is 29, I'm going to say meters per second. It's faster than miles per hour. Meters per second at 63.7 degrees north of west. And they're asking you, this is a velocity, okay? So this is your velocity. They're asking you, what's the velocity in the x direction and what's the velocity in the y direction? In other words, how big is this vector and how big is this vector? All right, so we don't know. See, we don't really know. We do know, we have to know by looking at it, that in this direction, the vector is going to the left. That we do, that's why we have to draw a picture. It's going to the left, and this direction, it's going up. Okay, so that'll tell us that this guy is going to be negative because it's going to the left. Okay, so we don't know. So the question is, how do we figure this side? And how do we figure out how big this guy is without having to draw it to scale and counting up little boxes? And that's where this thing comes in. So this is what we're going to show you guys right now. Okay, what the cosine is and what the sine is. So I'm going to go back to this sheet, then we'll go back to our example. So looking at this guy right here, I think it would have been nicer to label them, but they didn't. They put OB. OB is this magnitude of this vector, and OA is the magnitude of the resultant vector, but this is our hypotenuse, okay? It's our hypotenuse. All right, so let's look at theta. Remember that cosine is, what is it? It's cosine is not sine, it's adjacent over hypotenuse. Adjacent over hypotenuse. So we look at the theta and we go, who's opposite? Oh, that's this guy over here. Nope, we want this guy. So that's OB. Okay, there's my adjacent. There's my adjacent over the hypotenuse, which is OA. Okay. If that's true, which it is, then I'm going to multiply OA to both sides. OA to both sides. So my OA's cancel out over here, and I get OB is equal to OA cosine theta. Again, what do they do here? Multiplied OA to both sides. OA to both sides. OA's cancel out, and I end up with OB, which is, OB is this part right here, the magnitude of the x component. And that's equal to the magnitude of this guy times the cosine of theta. All right, let's see with my example. My example might be a little easier to see. Okay, so I'm going to redraw this. Redraw this, but it's not going to be to scale. All right, here we go. I'm redrawing. Not drawing this to scale, of course. Okay, So we know that this guy here is 29. And we want to know what this angle is here. That angle right there. All right. So the question is, let's do sine. We're going to call this one right here. This is V. This is my velocity vector. So this guy here, I'm going to call it the velocity in the x direction. And this is the velocity in the y direction. And when I add up the x component plus the y component, I end up with my resulting vector. Okay? All right, so let's look at the sine. What's the sine of this guy? Let's go. Sine of theta is equal to, oh, by the way, sine is, theta is 63.7 degrees. Sine of theta is opposite over hypotenuse. Who's the opposite here? Right here, Vy. That's the Vy. So the magnitude of Vy is the opposite of this angle, and my hypotenuse is this guy right here, it's 29. Okay, let me rewrite that. Sine of theta is equal to Vy over 29. Okay, if I multiply 29 to both sides, now I have the magnitude of just the y direction. So I have 29 times the sine of theta is equal to Vy. So let's plug it in. 29 times the sine of, what was it, 63.7. And my calculator here. I'm going to go, give me the sine of 63.7. Okay, there it is. And I'm going to multiply it by 29. Now, I didn't have to do it in two different steps, but there you go. All right, I get, let's call that 26, right? 25.998. Let's say that's 26. Hey, look at that. That's exactly what we came up with up here. All right, 26. Let's do the next part. We still need to figure out. So now we know that this guy is 26. Let's do the next part, Vy. So what is Vy? Well, we did the sine of this angle. Let's do the cosine. Let's do the cosine. The cosine of theta was cosine adjacent over hypotenuse. Adjacent over hypotenuse. So who's my adjacent here? Okay, opposite is this guy, Vy. Adjacent must be this guy, which is Vx. Okay, Vx. Vx. Oh. Okay, Vx over your hypotenuse, which is 29. Yeah, I see you guys, I labeled this wrong. This guy here is 26. Not this one. We don't know what this one is yet. All right, 26. This one is 26. Okay, so here we go. We want to know what Vx is. Well, we've got this 29 on it, so we multiply 29 both sides. Let me rewrite it. Cosine of theta is equal to Vx over 29. Okay, let's multiply 29 on both sides. 29 times 29. My 29s cancels out, and I get with 29, cosine theta is equal to Vx. Okay, let's plug it in. 29 times the cosine of, what is it? 63.7. 63.7. Okay, let's try that. All right, cosine of 63.7. There it is. And I multiply that to 29, the hypotenuse. And I get 12.84. 12.849, which is about 13. So this guy is 13. 13, and this one's 26, which is exactly what we started out with. Okay, so this is a little more than just a review of sine and cosine. This is actually using sine and cosines to resolve vectors, really what this is. All right, so let's finish this up. So this is saying, therefore, so if we got the cosine of theta is Vx, that's the adjacent, over V. So they call it OB over OA. We multiply OA to both sides, and we end up with OB is equal to OA cosine theta. Well, OA is your resultant vector. The resultant vector times the cosine theta will give you the magnitude of the x component. All right, let's go on this side over here. What is the sine of theta? Okay, sine is opposite over hypotenuse. All right, so what's the sine? Sine opposite. Who's the opposite of this guy? Got to go outside. There it is, Vy. It's the Vy, but they call it the, what is this? AB. Between here and here is AB. Yeah, you guys should have this in your packet. AB, that's the opposite, over OA, which is your hypotenuse. Okay, so again, we multiply OA to both sides, they cancel out, and we end up with OA sine of theta is AB. What's OA? OA is your resultant vector magnitude, and then just times the sine of the angle. And that's how you break down your components. Okay, so let's give a real example here. Here we have a little doggy, and you have a chain on him. And now instead of velocity, your vector is force. And you're pulling kind of hard, 60 newtons at perfectly an angle. So you measured it, of course, before you pulled him. You said, hold on a minute. And you measured the angle, 40 degrees. And that would be what? East of north. North of east. This guy right here. All right, so this is, you're pulling 60 newtons out and 40 degrees. So the question is, how do you figure out exactly how big is the x component and how big is the y component? That's what you're trying to figure out. All right, oh, here's another example of a vector. Let's say an airplane. An airplane, it takes off at 50 meters per second and at an angle of 60 degrees with respect to the ground, north of east. Okay, there we go. So you take that, imagine the box around it, a perfect box, a rectangle, anyway where you can see and actually visualize. So yes, you're gonna have to start sketching things. I'm not an artist, you don't need to be an artist. Sketching things here, so I can see the rectangle around here where this resulting vector is the hypotenuse. And from the hypotenuse, now I can figure out exactly how big is the x component and how big is the y component. All right, let's go back to our doggy down here. All right, our doggy. Running out of space here. Okay, so here we go. Let's figure this out. In this picture, you just drew the 60 newtons and you knew it's 40 degrees, but you don't know how big these guys are, the x and the y components are. So I go, what's the sine of 40? Well, the sine of 40 is, I'm going to call this F vertical. That means the force in the vertical component. Later on, you'll just be saying F in the y direction. F in the vertical, so it's opposite over hypotenuse. There it is, opposite over hypotenuse. All right, well, I want to know how big F vertical is, so I just multiplied 60 newtons to both sides. So there it is. 60 newtons cancels out. 60 newtons times sine of 40. Here, let me write it down. 60 newtons times 60 newtons. There we go, cancels out. And now I have 60 newtons times the sine of 40. Let's take our 40. Caramba. Let's take 40 on the calculator. Sine of 40. Actually, I want to show you guys, you can do it all at once. 60 times sine of 40. There it is, 60 times sine of 40. And there it is, 38.56, which is, they just put it as 38.6. There it is, 38.6. All right, let's do the cosine side. For that same angle, we did the cosine. What's the opposite? F vertical. So adjacent must be F horizontal, which, by the way, we end up calling F sub x. Much faster. So what do we have? Cosine of 40 is F horizontal divided by the hypotenuse. So this is the adjacent over the hypotenuse. Okay, so let's multiply 60 newtons to both sides, and that's how we get F horizontal all by itself. And we get 60 times the cosine of 40. 60 times the cosine of 40, let's do it over here. 60 times the cosine of 40. And there it is, 45.96. That was pretty close to, well, they just say 45. I would say 46. 45.9. That's what they say right there. Okay, so make sure you guys go over that. Here's a summary of the x component. The x component, if the vector is going in this direction, it isn't always. Sometimes maybe it's going the other direction, but if it's going this direction, then you know your a sub x component is going to be whatever this is times the cosine. So in this case here, it's a cosine of 40, and the a in the y direction, which is too light, maybe you guys should draw it, ay in that direction, would be 8 times the sine of 40. Okay, so you want to get really comfortable with this. On the back side, and I think your attachment might be a separate document. On the back side of your handout is an example of adding vectors. So we're not going to go over right now, but I just want you guys to see that your A vector is this blue one, and your B vector is this black one. When I add up head to tail from the A plus the B, here's my C. There's my C. And what I want you guys to see is what happens. Here's my resultant vector, the red one. What happens when I break down the red one's components, the X component and the Y component of the red one, compared to the A and the B? And you'll notice that all you do is add up all the X components together and you add up all the Y components together, and that's how you get the components for the resultant vector. We'll go over that more slowly later. So hopefully you guys get a better idea on that. Make sure you go through the worksheet on vectors if you want the extra credit, and then make sure you get really comfortable with this worksheet. So that's it for now. See you next time.